As we continue in Lesson 1 of Section 3 on the addition of mixed numbers, we're going to now look at a way to add mixed numbers symbolically. We will only use numbers and symbols to complete this addition calculation. The visuals are awesome in the sense that they obviously allow you to see what's happening, but if you had to draw out pictures every single time, that would be very time consuming. So the symbolic way will certainly help speed up the process. So for method 1, here's what we're going to do. Here's the algorithm, the recipe. We will add the whole number portions of our mixed numbers. We're going to add the proper fractions of our mixed numbers by finding a common denominator and adding numerators. Then we have a couple of things to consider. If the sum of the proper fractions results in a proper fraction, we combine it with the total number of wholes. If the sum of the proper fractions results in an improper fraction, we create more wholes until we are left with a proper fraction, and then combine this proper fraction with the total number of wholes. And as always, check for simplest form. And you're probably saying to yourself, oh my goodness, what is involved here? But as is typical in math, the process will become a lot clearer once you complete a few examples. Trust me. So let's do just that. Add the following. In A, we have 3 2/5 plus 1 1/5. I would like to draw your attention to the fact that in each of those proper fractions, your denominator is the same. It's a 5. That's going to make our lives easier as we go through this particular question. So if we look at the whole number parts first, we have a 3 and we have a 1, and we add those together and we get a 4. Then for the proper fraction pieces, we have a 2/5 and we have a 1/5. If we add that together, we will get 3/5. So just on the side here, if you need to see it, 3 plus 1 is 4. 2/5 plus 1/5 equals 3/5. Combine it, and you get 4 3/5. The 3/5 cannot reduce, so that would be simplest form. In B, we have 2 5/7 plus 4 4/7. Worth noting again, yep, we have a common denominator of 7 in each of those proper fractions. Now the process, let's add the whole number parts. I got a 2 and I got a 4. 2 plus 4 is 6. I look at the proper fractions. I have a 5/7 plus a 4/7. Copy down that common denominator, add the numerators, so I get 9/7. But please don't leave your answer as 6 9/7. Why? Well, because 9/7 is not a proper fraction. It's improper. And what it being improper means is that we can actually get another whole out of the 9/7, because 7/7 will create that new whole, and I'm left with 2/7 of another whole. So if you want here, we can say, okay, I got 6 wholes. I got another whole from the 7/7, and then I'm left with the 2/7. So 6 wholes plus another whole will give me 7 wholes and 2/7 of another. So when we add these two mixed numbers, we get 7 2/7, and that's simplest form. In C, 5 1/2 plus 5/8. And you're probably noticing a couple of things here. First of all, your denominators for the proper fractions are not the same, but that's okay. We can deal with that. We learned about that previously. And you may also notice that, gee, there's no whole number part in front of the 5/8. But that's okay too. That just means that right now we don't have, or we're not adding on another whole, and some we're just adding on another 5/8. So let's go through the process. 5 plus, well, there's nothing there, so we're still left with 5. And then we have to add up a half and 5/8. To do that, we need our LCD, which is 8. A half, the equivalent fraction is 4/8. 5/8 is already good. Already got a denominator of 8. So if I add up 4/8 and 5/8, that's going to give me 9/8. So far I have 5 and 9/8. Do we have an issue? Yeah, we do. Because 9 over 8 again, that is an improper fraction. We can break that down into an 8 over 8, which gives us another whole, and we're left with 1/8. So I can say now that 5 and 9/8, that's the same thing as 5, plus that new whole that we've created from the 8 over 8, and we have another 1/8. So in total, 6 wholes are created, and we're left with 1/8 of another. 6 and 1/8. In D, denominators are different for the proper fractions. No worries. Let's add up the whole number parts. So I got an 8 and a 2. That's going to give me a 10. I got a 6 and 5/12. Well, the LCD is a 12. I rewrite 1/6. Its equivalent fraction is 2/12. Remember, 1 times 2, 6 times 2. And we're adding on our 5/12. 2/12 and 5/12 gives us 7/12. So for the proper fractions piece, I get back 7/12. This time, we don't have to take it any further because 7/12 is proper. 7/12 cannot reduce. So our final answer, 10 and 7/12. A few more. 2 1/5 plus 1 1/4. Let's add the whole number parts so we get a 3. The proper fractions, I'm just going to take off to the side here again, and we're going to work through those. This time our denominators are 5 and 4. They're different. The LCD is a 20, so we're going to rewrite both fractions this time with a denominator of 20. 5 times 4, 1 times 4. 4 times 5, 1 times 5. Add them up. 4 over 20 plus 5 over 20 gives us 9/20. A proper fraction in simplest form. We are done. F. 6 and 7/8 plus 2 1/6. The whole number parts. 6 and a 2 is an 8. Our denominators are different in our proper fractions. We're going to take those to the side and add them together. LCD for 8 and 6 is a 24. We need to rewrite both fractions here. 8 times what is 24? That would be a 3. 7 times 3 is a 21. 6 times what is a 24? That would be a 4. 1 times 4 is 4. Add them up. 25 over the LCD, 24. 8 and 25 over 24. Better not leave it there, because 25 over 24 is an improper fraction. I can get a full group of 24 out of 25, and that will leave me with 1/24. This 24 over 24 gives me another whole. So I got an 8, I got another whole, and I got 1/24 left. Final answer, 9 and 1/24. One more example, and this time we're going 3 mixed numbers added together. But no worries, we can do this. Let's keep our process the same. I look at the denominators of my proper fractions. They're all different, but I'll deal with that in a sec. My whole number pieces, I got a 3 and a 5 and a 1. I add 3, 5, 1, I get 9. Off to the side. Let's add up those proper fractions. So the 2, the 3, and the 4, what is my LCD for those numbers? It is 12. I have to write 3 equivalent fractions. A half will be the same as 6 over 12. 2/3 will be the same as 8 over 12. And 3/4, the same as 9 over 12. Add it up. Well, LCD is 12, 6 and 8 is 14, 14 and 9 is a 23. So far I got 9 and 23 over 12. Are we done? The 23 over 12, I can get a full group of 12 out of that, which will give us another whole, and I have 11 twelfths left over. So I can break the 23 over 12 down into another whole and 11 twelfths. Combine it all, 9 and 1 is 10, and 11 twelfths. Cannot simplify. Final answer. Now I would like you to proceed to the next video in this lesson.